Hello, everyone. Thank you for joining today. We are going to kick off our Kubernetes Master Class today shortly. Just giving people a few minutes to get logged in and situated with the GoToWebinar platform here. So while we wait for everyone to get logged in, I'm going to go ahead and go through a few housekeeping items, and then we can jump into the presentation. So today, our topic is on K3s support with Rancher 2.4. I'm your host, Connie Lynn. I'm the manager of global events here at Rancher. And today, our speakers will be Hussein, senior software engineer, and Sebastian, software engineer here at Rancher. You guys there, you want to say hello?
Hello.
Hello.
Hey.
Hi.
Oh, great to have you here, guys.
Thanks.
Thank you.
Cool. So a couple housekeeping items about our webinar today. If you've joined us for previous classes, I'm sure you're familiar, but for those who are new, the masterclass today will run anywhere from 45 to 75 minutes, followed by an official Q&A. Please ask questions. We love questions, so make sure to utilize the questions tab on your GoToWebinar panel. You can see all the different categories there and mouse down to questions, and we'll do our best to answer them throughout, but we'll probably hold most of them for the Q&A at the end of our presentations. A quick reminder that this session is being recorded. We will share the recording along with the slides in the next day or so with everybody. So if you do need to jump early, no worries. This will be made available on our YouTube channel. We also have our user Slack channel. There's a masterclass channel on our Rancher user Slack. So head over to slack.rancher.io to join the conversation. And for those of you who are interested in other trainings, we do have an Intro to Rancher training every week on Thursdays, and also a bunch of other virtual events going on. So if you're interested, head over to rancher.com/events and you can check out our entire upcoming calendar. So with that, it looks like we've got most people logged on now. I'm going to go ahead and hand it over to Hussein, who will get us kicked off today with today's topic.
Okay, so hey everyone. So my name is Hussein Galal. I'm a senior software engineer at Rancher Labs. I'll be speaking today about K3s, and hopefully at the end of the session you will get a better understanding of what is K3s and how to use it in production. So what is K3s? K3s is a lightweight Kubernetes distribution, which, if you heard that term before, distribution in Kubernetes world basically means a way to get Kubernetes up and running. So most of the current distributions now are basically tools to deploy Kubernetes. However, what we have done for K3s, it was tailored for a specific use case, which is very lightweight and simple, and plus that it's designed for production from day one. So as I said, it's very lightweight Kubernetes. The K3s binary, it's a single binary, and it's just about 50 megabytes in size. It has a very low memory and CPU footprint. So the actual footprint of K3s when it runs is basically 300 megabytes for single node configuration, and that would be server plus the worker, as I will explain in a little bit in the architecture slide. K3s also a CNCF certified distribution, which basically means that it passed the conformance test designed by Kubernetes to certify Kubernetes distribution. So one of the most important thing that we have that sets K3s apart from other K3s small distros like Minikube or MicroK8s is that K3s was designed from day one to work on production systems. So it follows the best practices to install Kubernetes, and it's secure by default. So due to its lightweight nature and the point that we discussed before, it makes K3s perfect to work on edge devices. Right now, we support running K3s on ARM64, and people are already doing very exciting things with running stuff like Home Assistant with K3s on Raspberry Pi and other stuff. So why exactly K3s is different from other distributions? That's one of the kubeadmin, for example. In addition to it's really simple to get Kubernetes up and running, we have done a significant amount of work beyond what we can get with just running kubeadmin or running Kubernetes using kubeadmin. So one of the things that makes K3s different is from other distribution is that K3s does not depend on any external dependencies. So basically, it can work on empty root on any Linux system with /proc, sys, and dev mounted. So you don't have to install any prerequisites tools to run Kubernetes. So it's also K3s is a self-extracting archive. What does that mean? So K3s, when it runs, is just a simple binary. But when the first thing that K3s does, it extracts an archive that has a user space of tools that can be used with Kubernetes, and Kubernetes depends on these tools, so you don't have to install any prerequisites tools before running K3s. So one of the major developments in K3s is Kine, which is a separate project that develop an etcd API, which is used in K3s to support different database backends. So Kine is basically an etcd shim that takes any etcd request and translates it to several backends, several SQL backends like MySQL, Postgres, and SQLite. So Kubernetes can run with in K3s can run with MySQL and Postgres and SQLite in addition to etcd. So in addition to that, K3s includes tons of controllers that support various functions, which include manifest auto deployment, Helm controller, and network policy controller, load balancer controller, which we'll talk about in the next slides. So everything we developed in K3s can be replaced or disabled. That makes K3s very swappable. You can disable any feature that you don't want to utilize and enable other feature. For example, you can disable Flannel network plugin, which we install by default, and install anything else. You can disable containerd and run Docker and so on. So let's talk about K3s architecture a little bit. So if we take a look into K3s architecture, it basically involves two processes, the K3s server and the K3s agent. So the server and agent run separately, but if you run the server by default, you will see that the server has an agent process embedded within it. So when you run K3s server, just like that, you will get a server process, and embeddedly you will get the agent process into it as well. So what are the several components that runs in the server and agent? So by default, when the server runs, it generates then and install the directories and everything else, and then runs the basic component of a master node process, which is API server, scheduler, and controller manager, and of course the database backend which is SQLite by default. So when you run the server, you get the main master components node in addition to the tunnel proxy, which I'll talk in a minute. We also have the K3s agent, and it runs different components than the server. It runs kubeproxy, kubelet, and the network plugin, of course, and it runs also containerd for the container runtime to run the pods, and as well as tunnel proxy, which I'll talk in a minute. So if we like elaborate on that, we have the server process runs the controller, cloud controller, and the API controller, cloud controller, scheduler as a part of the K3s process. We have also the SQLite as a storage backend by default. We have some bootstrap for the certificates. So when you run Kubernetes in HA fashion, you need to have like common certificates between the servers. So when the first server runs, it saves its certificates encrypted into the database. We also have the reverse tunnel proxy, which we saw here, the tunnel proxy between the agent and the server. So the tunnel proxy, it's a trick done in K3s, which eliminate the bidirectional communication between the server and the agent. So normally kubelet needs to communicate with kube API like any other components, like controller manager or scheduler. But also kube API will need to communicate back to kubelet, which means new firewalls need to be opened between the two servers and on every agent you run. So imagine you have 1,000 agents, you need to have a firewall set up on each of them to allow communication back from kube API. So the tunnel proxy has been done to eliminate this problem. So it will open a connection from the kubelet to kube API, or basically from the agent to the server, and the server will reuse this tunnel communication to communicate back to the kubelet. So you don't have to open any firewall or do anything specific to the agent to enable communication back from the server. So as we mentioned, so the agent runs kubelet and kubeproxy, which is a worker components for Kubernetes. It also runs Flannel as an embedded process. It runs containerd daemon by default, so you don't have to install any runtime unless you choose to install to run with Docker. So then you will have to install Docker beforehand. But by default, it is just K3s runs containerd within the server within the agent process, so that you don't have to install any prerequisites runtime for running containers. Also, each agent has internal load balancer, which proxy requests to different server to handle HA situation. We'll talk about that when we go into the deployment architecture for the agent and servers. And finally, the agent runs network policy controller. So by default, we run Flannel, which doesn't have a controller for network policy. So we have our own network policy controller that watches for any network policy and update the IP table chains to apply this policy without the need of to install Calico or any other specific network plugin that handle net policies. I'm going to explain now the deployment architecture. So we have so you can install K3s in different fashions. So the first deployment architecture that you can handle is the single node architecture, which is very simple. You just run one server that has SQLite in it, and the server will, as I mentioned, it has agents embedded, so you will get all the Kubernetes components that include controller, scheduler, API, and SQLite, obviously, and then the kubelet and kubeproxy. So this is a single node cluster. The agent is embedded in the server process, as I mentioned, and it's really optimized for the edge because you don't have to have external database or any other prerequisites, and also it's really has a low memory footprint, which can be installed in different devices. So the problem of this single server cluster is there is no HA support. So if the server is down, then the deployment is down. So another deployment architecture. So going back to the command that to run this is how simple to run K3s in production even. So we just run a curl command that have the script for installing K3s, and you just execute it on any server that you have. This will install K3s, and the K3s server will have everything that we talked about within this server. That includes containerd and the Kubernetes component, SQLite for the database, and install and run the pods. And in the demo, we'll show how it's really fast to do that within like 1 minute or few minutes. So another deployment architecture which is really popular is the single server multi-agents. So this basically have one single server that has embedded SQLite database, SQLite database as well, and it has different agents that connects to this server, and all of them connects to one server. But the problem of this deployment architecture as well is there is no HA support as well. So if the server is down, then the cluster is not really accessible. And I have to mention that agents connect securely to the server using a token. So when the server starts, it generates a token, a random token that can be used within the agent. So you take this token and you start K3s agents with it. And also you can specify the token beforehand. So you can start the K3s server with a specific token and the agents with and connects and make the agents connect with the same token. This really helps with any automation for running K3s on with different tools like Terraform or Ansible or something. So this is how you run server and an agent. Is how the commands work. So the server just run the server process and you specify the token beforehand. You can also eliminate this part and it will generate a random token for you, and you can take it and put it in the agent. The agent will just start an agent process, as you can see, and it points to the server token as well that connects to the cluster. So now let's talk about the HA deployment architectures. So the high available architectures has two modes. The first mode is HA with external DB, and the second mode is HA with embedded DB. And so we'll talk about the external DB first. So the external DB first just have 3 server or more, or 1 server, 2 servers, 3 servers, more than 1 server with that connects to an external database. So the external database can be MySQL, Postgres, or etcd. Obviously, it can't be SQLite, and so you should have an external database set up beforehand. And that's actually one of the drawbacks of this method, is that you have to install the external database beforehand before running the servers, and each server will connect to this database with the username and password you set up for the database you have. Also, the agents here will register using a fixed registration address. So basically, you can have like a DNS pointing to or load balancer pointing to the servers, and the node pool can and the workers can just connect to the server cluster using this registration address. Once an agent connects to the cluster, there is an internal load balancer that we set up embeddedly in the agent process that can discover the IPs of the servers automatically without any intervention from the user. So it discovers the IPs from sorry for that. Yeah, so basically when an agent connects to one of the servers, it has a load balancer internally that can figure out what are the services, what are the servers that are running, and then connects to them automatically. So basically, there is no quorum needed here for the servers. So if 2 of the servers are down, the remaining server will still be functioning normally, because the database is basically external to the K3s cluster. So this is how to run the server and run the agents. So basically, you can just run the curl command with the server with the token that we talked about, and you point to the database using the database endpoint option. So the database endpoint flags will take the data source name for the database that includes MySQL, Postgres, or etcd, and it has a username and password, and points to the host name of the database, and just finally write the database name. So the agents will connect normally like it connects to any server using the server address and the token. The agent doesn't have anything specific or special for the HA mode. It just connects to the server like any other mode. So finally, we have the last deployment architecture. This is experimental architecture, but it's available now in K3s. So you can just run 3 servers with SQLite. SQLite is SQLite and Raft. So using Raft algorithm, it sets up SQLite in a cluster mode, and the SQLite can communicate with each other so that it can set up a cluster. So this when you run the architecture, when you run this architecture, the first server will bootstrap a cluster using SQLite, and the other servers connect to the first server, and then it will set up a cluster embeddedly, so you don't have any external database here. So the database runs embeddedly in each server using SQLite. The only problem with this architecture, is SQLite basically using Raft, so it's quorum based. So you must have at least 2 out of 3 servers that's running, so that the cluster will still run or still function correctly. If the 2 servers are down, then the last server will lose communication, and the cluster will not be accessible. So this is how to run K3s deployment architecture using embedded DB. Just run the first server using normally using the token and -- cluster init, and the other servers will use they will just connect to the first server. So this is really similar to how the agent connects to the server. So the other server will just use the same token, but obviously it will run the server process and just connect to the first server with the same token and the IP of the first server. So this is how the deployment architecture happened in K3s. So basically, we have 4 modes that we explain. So I'm going to talk next about the features that we added around K3s. So K3s is not just Kubernetes, functional Kubernetes, but there are like a lot of features around it that makes it very special. So the first one is the manifest deployment controller. So basically, the manifest deployment controller is a controller that runs in K3s, which listens or watches this specific directory or data directory in and the server manifest. And if any YAML file or JSON file happen to be there, it will install it as an add-on. So basically, if you have a YAML file that installs a pod or a specific service or anything, you can just drop it in this directory, and the manifest auto deployment will just pick up the YAML and will install it. So you can skip files there using .skip suffix, or just remove the file from the directory, and it will not be picked up. So by default, K3s comes with some add-ons that includes metric server, CoreDNS, an ingress controller that's using traffic, and a local storage provisioner for the storage class. So this is how the manifest auto deployment work. Another control is the Helm controller. So instead of installing Helm on your machine and just install different releases, we made a controller that really simplifies the process of installing Helm charts, and not only that, keeping a track and maintaining the Helm charts during the life cycle of the cluster. So basically, we created a custom resource definition, or CRD, that called Helm chart. And this custom resource definition that has a specific spec that you can point to the chart or the URL of the chart, and you can pass the settings in this chart using like that values content, or using set for different values. So you can add any option or pass any option to the chart using this CR or CRD. So the Helm controller works with Helm version 2 and Helm version 3. So one of the spec is the Helm version. You can just specify if you want to use version 2 for this chart, or use version 3 for this chart. And Helm works with secrets backend. So if you are familiar with Helm works with different backends to store the release information. The default mode is storing the release information on your disk from the place that you run Helm. But another mode is storing the release as a config map, or storing the release information as secrets. So we chose to use the Helm to make the Helm controller save the release information as secrets in the Kubernetes backend. So not only you install Helm using K3s, but you store the release information in K3s as well. So as you can see here, the Helm object, the Helm controller will watch the API for any Helm chart CR, and then when it finds one, it will just install it. And if the Helm CR is removed, you will see that it got deleted afterwards. So we have a different controller as well called service load balancer controller. So if you're familiar with the services in Kubernetes, services has different types. One of these types are the load balancer type, which is really utilized using cloud providers like AWS or Azure. So when you create a service with a load balancer, the cloud provider will watch for that and will create a corresponding load balancer in their in the cloud area. And however, you can just install some of the controllers, some third-party controllers like Metal LB controller. So instead of that, we have an embedded service load balancer controller that watches for any service that has load balancer type, and it will create a load balancer for it, a load balancer pod for it, which is based on traffic, and you can exclude nodes from it. It's really simple and really easy to use. You can just have it can be accessible through any node using the service load balancer pod. We will show that in a minute in the demo. So I'm going to move to the demo. I just want to see if there are any questions that can be answered now.
Hi. So there was one question on if you could maybe elaborate a bit on the single binary, no dependency from the first slide. People are asking if it's actually a single process or just a single binary, but if it's also a single process, and what the exact requirements are for running K3s. So maybe if you can give a bit more detail on like what it actually does.
Yeah, of course. So the K3s is built as a single self-extracting archive, which basically means that when you run K3s, it's just a single binary that you can download from the releases from GitHub, and you can just run it on any Linux server. Basically, when you run K3s, it will create the first thing that it does. It creates a data directory in the data dir in var lib rancher K3s. This data directory will include all the user space tools that you need to run K3s. So you don't have to like, for example, it have a queue that can be used using Kubernetes. So basically, you don't have to install any other prerequisites to run K3s on any server. So these user space tools are built on build root. If you're familiar with this project, we have a similar fork from that. It's called K3s root, that includes all the user space tools that can be installed when the K3s starts. Hopefully that answers your question.
Yeah, I mean, they can, yeah, please reply. If it doesn't answer your question, please reply in the question section and we can elaborate. So.
Okay. So if it's fine, I'm going to move to the demo. Okay. So yes. I wanted to show how you run a single server with multi-agent, also embedded database using SQLite, and finally using external database like MySQL or Postgres. So let's start with single server multi-agents. I have here 4 servers. These are the IPs of the servers, and demo 0, 1, 2, 3, 4, and 1, 2, 3. And I'm going to run one server and multiple agents, as you can see. So let's sh to demo 1, 0. And just run the command. This is a really simple command. If you can see here, it installs the script run the server process with a specific token. And as I mentioned, the single server multi-agents run SQLite by default. So when you run that, you will have a SQLite backend. So, yep. Here you go. So it installed K3s. If you do kubectl git nodes, as you can see, we didn't install any tools. So kubectl is available. Other tools are available through just you can just run them and it will they will run. So that actually utilized by the self-extracting binary that I mentioned before. So let's do kubectl git nodes again. Yeah, and now the node is ready to use. This is a master node. So if we want to run agents, let's copy that and get out of this server and demo to sh to the demo one and just run the command. Let me explain the command here. So this is runs the script and run the agent process instead of the server now. And the agent will point to the server, the first one that we just created, and with a specific token that we have. So running this script as well, it will pull up the script from GitHub and run the agents. So yeah, sorry, let's do that in the other, let's do the same command in other servers as well. As you can see, it's really simple to use. There is no prerequisites and nothing except just running the command. Let's sh to the first server, the master server again, to run the kubectl command and do kubectl git nodes now. You will see that we ran the first server and we ran two agent servers, as you can see here. So if you do kubectl git pods, you will see all the pods have been initialized. And as I mentioned, we metric server by default. We have install traffic ingress, and we have core DNS. And finally, the storage class that we have by default, the default storage class, which is local path provisioner, which is another Rancher project. It's really cool. You should check it out. So this is a first deployment architecture. So this is based on SQLite. So if we go to var lib rancher K3s, you will see that we have data mentioned, which runs. Yeah, here you go. These are all the binaries that K3s installs when it first starts. So if you do go to the binary, you'll see that all the binaries that we have in the user space that we use in K3s, and we have different configuration for containerd and such. So if we go to the server, you will find out that we have the database here, which will be SQLite StateDB, which is based on SQLite, and you will also find all the certificates in the TLS directory that includes the CA certificate and a certificate for each component as well. So finally, this is a token that we passed to the server, and the agent uses this token to connect to the server. So yeah, that's the first deployment architecture. Let's move to the different deployment architecture, which is embedded database. So basically, this is based on SQLite. We don't have to install any external database. We will run 3 servers. As you can see, all of them are servers. And the first server will just run with cluster in it, and the other 2 servers will have the server IP will point to the server to the first server that we have. So if we sh to demo 2 0, yeah, sorry. with Ponto user. Just copy that and paste it here. This will run a server with SQLite. And let's sh to the second server and run this command. So let me explain this command real quick. So this is runs the script with a server process, and it will point to the first server with the same token that we agreed upon from the beginning. So let's do the same thing at the final server. And we can just run now kubectl command kubectl get nodes. You will find out that we have 3 servers running at the same time. It takes like a few seconds until it starts. Yeah, here you go. So all the servers are ready, and they all the master components. This setup architecture works with SQLite embeddedly, and as I mentioned, it's quorum based. So if 2 of the servers are down, then the cluster will not be accessible until one of them are back up again. So let's move to the last deployment architecture, which is external database with status. So we run MySQL at the beginning. So this is the only drawback of this method is just you have to run the external database. I'm just going to demo that we run MySQL here. So obviously you can choose to run MySQL any way you want. After that, I will just run 3 servers and with the same token, and point to the database that we set up in the first step. So the database here I will run with the root user and using the K3s pass, and then points to the IP of the server and choose any database that I want, which in that case is K3s DB. So let's sh to demo3 0 and run the command. There you go. To install MySQL with a specific root password, and then sh to a different server to run the server command. I think yeah, there you go. So I want to talk a little bit about the script here. So the script runs several checks on how the system is running, if it's running systemd, or in case of you running OpenRC in Raspberry Pis or something, and it downloads the latest release, and then it creates symlinks to the K3s, which has wrappers for kubectl, CRI-CTL, and CTR, and installs some uninstalled script, which I will talk about in a minute, and sets up systemd service for K3s as well. So you will have systemctl available for K3s as well. So if you do systemctl status K3s, you'll see that it's a systemd process running, and you can check out its logs and so on. So if we do kubectl get nodes here, you'll see that one server has been running and connected to the MySQL. let's just run another server quickly. And do kubectl get nodes now. You'll see, yeah. Oh, it's failing. Okay. Let's see why it's failing. Oh yeah, so I left one space after the. Here you go. I'll just fix the command and run the install script again. This is one of the cool things that we have in install script. So if you have something wrong in the command or something, you just fix it and run the command again, and now you should find kubectl K3s working. As you can see here, it started the second server normally, and two of the servers. This is not quorum based, so it's really safe. Server.
Sorry, you just cut out for like 10 seconds. So
Yeah.
can you repeat that?
Oh, sorry. Yeah. So this mode is not quorum based. Can you hear me now? Hello?
Yeah, I think you cut out for another 5 seconds, but we can hear you right now.
Yeah,
So
I'm really sorry. So you can have more than one server in the cluster connecting to the database. You can have two servers, you can have one servers, and so on. And so if we sh to the first server here and do docker ps, you'll see that we have MySQL running. Let's exec to this one, 39d, and do MySQL -u root -p K3s pass. Sorry. Here you go. So if we do show databases, you'll see that it created a K3DB database for us. And if we use this database and show tables there, you will see that it created a table called kind, which it stores any information for the Kubernetes cluster in it. And you can select, for example, count from kind, and you'll see it writes SQL statements to it. It keeps writing to it, and that's how actually kind works. So this was the deployment architectures. I just want to demo last thing that I want to demo is a manifest deployment controller. So for example, here I have a Helm chart that have word is a CR Helm chart that will install the WordPress Helm chart and sets up a different port for it to be accessed. And I'm just going to take that and or SP that WordPress to Ponto at demo 1.0. Here you go. And I'm going to SH to demo 1.0. And as I mentioned, so there is something called the manifest auto deployment, which is in varlib rancher K3s, or watches for files in varlib rancher K3s server manifests. So any file that you actually put in there will be picked up by the auto deployment and will be installed on the server. So what I have here in this file is a Helm chart CRD. So when I put this file into this directory, it will be picked up by the auto deployment manifest and will be installed the Helm chart CR. After that, the Helm controller will watches for the Helm chart in the system and install the Helm chart that we talked about. So if we copy home Ubuntu WordPress to var lib rancher K3s server manifests, and just like that, if we do kubectl git pods, first git kubectl git Helm charts, you will see that WordPress has been created there for 5 seconds, and if we do kubectl git pods, you will see that Helm controller will start installing Helm installer here has been completed, and it installed the chart, and you can see the resources of the Helm chart that includes WordPress and the MariaDB for the database. It will also create the load balancer service of load balancer type. So if we do kubectl git services -a, you'll see we have the Helm chart installs a WordPress service of a type load balancer, and then it will be picked up by the service load balancer controller that we talked about in a few minutes ago. So if we do kubectl git pods, let's wait until it's in a ready state. Usually takes a minute or two. That depends really on the application itself. Here you go. So if we run, let me show that. If we do HTTPS demo 1.0.2.4.4.4.3, that's the IP that I have for WordPress, and you can see that WordPress has been installed. That was my part of the presentation. So I'm going to hand over now to Sebastian to talk about Rancher and K3s and how you can integrate both. So here you go.
Yeah, there's two more questions I wanna
yeah, sure.
do before we move on. One is, you mentioned the DQ-Lite storage backend for HA.
Yeah.
The top question in this webinar would be when it will be production ready, or what is the status on that backend or that on DQ-Lite?
Well, I'm not really sure about the plans for getting DQ-Lite production ready, but right now it's still experimental, and we haven't figured out all the bugs around it yet. And but hopefully, it will be production ready soon. But right now there are no plans actually.
All right, thank you. And the other question was for the person that asked the question on the single process binary from earlier. Can you do a PS on the system running K3s? I think
sure,
he wants a PS3 or something like that to see the running process.
So when you run that, I understand what he wants to ask about. So so basically you have so any pod, you will find out that any pod in the system will have its own process. But for K3s itself, let's do ps aux grep K3s. So K3s runs embeddedly, run everything in it embeddedly. So this is the agent, and you will not find, like, for example, Flannel running here, but it's running within K3s. Sorry, this is a server, so you'll find also agent process running embeddedly. You'll have every component running within this server process. So you can find containerd running separately, and the processes for the pods running separately, like metric server or core DNS. Obviously, these will run as different processes, but K3s itself will have everything running in it embeddedly. So, for example, if we take a look at the K3s logs, and so this is a really cool part. So it starts Kubernetes, lightweight Kubernetes. First thing that it does, as I mentioned, it decompress the self extracting archive for the binary in this directory, and it runs KINE, which is the etcd gem that we talked about, that translates from etcd to SQLite backends, and then runs the components embeddedly. So the kube API server, and these are the logs for kube API server. Afterwards, you can find the controller manager. So yep, sorry, controller manager, as you can see here, and you can find several other components running within this server process. So yeah, to answer your question, the process runs embeddedly within the server process. Yeah.
All right, thank you.
Thank you. I'm going to stop showing. Yeah.
All right. Can you see my screen?
Yes. Yeah.
All right. Okay, thanks Hussein for explaining K3s to us with all the demo and examples. So what I'm going to talk about is about integration between Rancher and K3s. So Hussein explained what K3s is, how it's built, architecture, and what it can do. Now, obviously, Rancher is our management platform, which you can use to manage clusters. And obviously, when we have built K3s as a method to create a Kubernetes cluster, and basically with all the options it has and provides, we want to be able to manage K3s clusters in Rancher as well. So I will be talking about, that's the first bullet, managing K3s in Rancher, which basically involves importing your K3s cluster. So basically the K3s cluster that Hussein just created, you can import it into Rancher, and then based on certain characteristics, it will be made a K3s cluster, and it will get options to it will get an option to upgrade that cluster, so upgrade the version of that cluster. And I also added the two other bullets, which are the Rancher HA installation, which is now from starting with Rancher 2.4.0, version 2.4.0. You can also run Rancher HA on a K3s cluster, where it was only possible to run that on an RKE cluster before. And I also, for completeness, I basically included every relation between Rancher and K3s, which is a single node Docker install, which is still heavily used for POCs and tests, and just, I mean, it's basically the quickest way to run it. So I will quickly touch on how that works, how people can look up how that is actually integrated. Okay, so moving on to the biggest subject, because managing K3s and Rancher is basically the big part of this presentations. The other are more mentions, and I mean just a quick direction of like, okay, this is where you can find integration. But the biggest part of this is basically how is it possible to manage K3s and Rancher, and how does it work technically, because it's in the end a masterclass. So I want to give you some pointers on how is this created, how does it work, and although when you see it working in a demo later, so basically it's a one-click upgrade of your K3s cluster node, it's still in a masterclass nice to know, like, okay, where are the decisions made, where are the deployments made, and how does it actually go through a certain process, especially if you want to do more advanced options, or you want to change the process a little bit to your liking. It's nice to know what options you have, because based on the process flow of like, okay, I click on this button and something happens, knowing what happens in the background helps you understand the process and helps you understand how you can influence the process. So hopefully after I'm done explaining the process, you will be able to know how it works, and now how to influence, or even just requesting features or reporting bugs. So like I said before, imported clusters in Rancher are the ones that are in scope. So creating clusters in Rancher, even in 2.4, 240 and up, basically the 2.4 range, is still based. The custom cluster option that you can use to create clusters is still based on RKE. So that's our other method of creating clusters, but that's still based on RKE. So the scope for K3s and Rancher, or managing K3s and Rancher in 2.4, Rancher 2.4x, is imported clusters. So you'll still need to create the clusters using K3s, which is shown by Hussein before. So either way that you want to set up your cluster, you will still need to create your own K3s cluster. And then to manage it, you can import that cluster into Rancher, and then based on the K3s server version, which you can see on the bottom here, the server version for K3s, the Kubernetes version, and the K3s in there. So the distribution that we built, the version that we create has K3s in the version number, and that's the point where Rancher recognizes that it's not a common imported cluster, because next to managing K3s, Rancher can manage any Kubernetes cluster. So if you have basically a Kubernetes cluster that is created by any distribution, so that can be anything else than K3s or RKE, we will provide you with an import command, and then that Rancher will be imported into Rancher. The only difference is, based on the K3s in the server version output, we'll recognize, okay, this is a K3s cluster, and that will trigger the functionality in Rancher to say, okay, this is now not a regular imported cluster, but this is now a K3s cluster, and that will make the option available to manage it. And in this case, that is an upgrade. So I've added the link, and we will share the slides. I've added the link in the slide. That's where the link to the code where the cluster provisioner, which is a controller in Rancher, which is as it says, responsible cluster provisioning, will detect the K3s in the server output and will mark it as a K3s cluster versus an imported cluster. This is also part of the demo after all those, after all my slides, where we will actually see, although it's a brief moment where it will switch from imported to K3s, but it will be shown as, hey, okay, this is an imported cluster, and then it will be switched to a K3s cluster. Okay, so this looks pretty daunting, I would say. Like when I was creating these slides and I was going through all the components, it's like, okay, this is a pretty long list of like components that are involved. So basically what Rancher does is, like, everything that we are gonna be talking about today are components that are chained together into an action in Rancher. So in Rancher, we'll be having an imported cluster, which is marked to K3s based on the server version output. And based on that, Rancher will give you a possibility to upgrade the version of the cluster. And if you change the version, then certain actions will be taken to get you into a cluster that is upgraded to that version. And other components that are involved in that process, so that simple click, these components are what are all involved in all those steps. So we'll be going through all of those components, and it could be, like I said, it could be daunting because I'm going to talk about all these components and what they do. The good thing is, I would say, and I'm going to start with the first one, every component I'm going to talk about, in this case, I'm going to start with the most important component, and that's the system upgrade controller. We'll have a GitHub repo, obviously, describing the component, and all those components are, some maybe more practical than others, can be used as is on their own, right? So we chain them together because we need certain functionality, and we pass certain values from one and to another to make sure it all works. But basically, let's start with the first component, the most important component in this case, the system upgrade controller. This is a controller which basically can also be used just with K3s. So if we don't think about Rancher and we just think about the system upgrade controller, and you will visit this GitHub repo, it will actually describe a method to upgrade your K3s clusters using this component, and that is without Rancher. So if you don't have Rancher and you just want to upgrade your K3s using the system upgrade controller, this component can still be deployed, can still be used. And I'm gonna not completely explain what system upgrade controller, what the architecture is and how it works, because that's it's already been done. So you can find 2 webinars links to presentations in that repo describing the design and how it was designed and how it works. And secondly, it's basically going to be very long to explain every component in detail. What I want to do is I want to explain the basics of it and then how it ties into the Rancher and K3s relationship. So I want to give you just enough that you know how that relationship works between Rancher and K3s. And then if you want to expand on that, obviously I give you all the links of like, okay, please go look here. If we can expand on this, if you want to do it on your own, maybe you can improve system upgrade controller with something that you want. And then we can port it back into making it manageable with Rancher, for instance, stuff like that. But that's basically the path that I designed this presentation for. So in short, the system upgrade controller introduces a new CRD. And for people that don't know what a Kubernetes CRD is, it's basically a custom resource in Rancher, which we obviously designed. And based on that plan CRD, in that plan, you can basically design a way to upgrade or have your nodes in a certain state. So for instance, I mean, there are a lot of options, but in this case, it's the version that we want to change, right? Like we want to go from version A to version B. Like I said, the plan has many more options, but we're going to focus on the plan and we want to change the version. That's the scope of, that's also the scope of managing K3s and Rancher. So the plan CRD, you describe a certain state of the node that you want the nodes to be in, and then that system upgrade controller will spawn or will create jobs, Kubernetes jobs that upgrade your nodes. That's basically what happens. And then the plan, like I said, the focus of this presentation is upgrading. So the plan can be configured with a specific version. So hey, I'm creating a CRD, a plan CRD, and I describe a version parameter, and that version can either be a specific version. Hey, I want to go from 1.16.5 to 174 as described in this slide, or you can have a release channel. So we have a live URL where you can have specify a channel, in this case stable, or obviously we have other channels which you can configure, and then you will be on the channel, similar to if people work with probably the best example is the now EOL container Linux, which also has the channels. So we have stable channels which you can subscribe to, and then based on that you have a stable release, so you'll always be assured of the stable release. I believe you can also pin to a specific version, so you'll say, okay, I want to be on 1.16 or 1.17, and then you will always get the latest version for that version, right? So if you say I want to be on 1.17, so I don't want to go, if stable goes to 1.18, I would never want to go up a version, then you can just put it on 1.17 and it will get the latest version of 1.17. How this is provided will be in the next slide. So how this endpoint works and how this is possible, because GitHub gives you a lot of options in terms of releases. Obviously, we release everything on GitHub, but it still lacks on like release channels, and especially if there are a lot of different versions, it lacks on management of like different release channels. So we made something which is behind this URL, which I will talk about in later slides. So like I said, to use system upgrade controller, you need to deploy it and create a plan. This is basically if you go into the repo and you want to use it for K3s, K3os, or any other example that is basically in that repo, because we have a lot of example plans. That's the way that you would use it. And then the relation in Rancher is, in Rancher, that's automated, right? So the whole the reason of this presentation for managing K3s and Rancher is that we made it possible in Rancher to first detect K3s and then give you an option to upgrade the version and say, I want to upgrade it. And then everything that is needed, which is, this is one component that is needed amongst others, will be all done for you. But it doesn't mean that you can do it on your own or that you can influence that process by using the components yourself. That's the best thing, or one of the best things of open source, obviously. Okay. So moving on. Sorry.
Quick question. Would you be able to enlarge the slides
oh, sure.
to full screen? Yeah, so that way it could be a little bit clearer.
Is this better?
Great. Yeah. much clearer. Thanks.
Okay, so the next component in line. So we started with the system upgrade controller, which, like I said, has a plan CRD, introduces a plan CRD, which creates jobs to upgrade the nodes. That job that is created is a highly privileged job and uses this image, which is the K3s upgrade image, which will actually execute the actions needed to upgrade. Right. So we have the system upgrade controller, and you give it a plan. It will spawn a job, and that job will do the actual work, and that job will actually have two images, I would say. So one image is it will use kubectl to drain the node, so to do a proper upgrade, and then it will actually use this image to actually upgrade the cluster. And why does it need so much privileges? Because it actually needs to find the running process, so find the running K3s process, replace it, and kill the process, so that the supervisor, which Hussein talked about earlier, will spawn a new process. So the supervisor will check the process state. It will be killed. There will be a new process created, and that new process will then use a new binary, and then it will be upgraded. So that's why it needs high privilege. So if you want to use the system upgrade controller, this is the image that will be used by default. So if you go into this repo and you find the logic and the script that is in there, you can actually find how it does that and how it works. But this is another component in line that the system upgrade controller uses to, like I said, create a job. In that job, there are two containers, which is one is the kubectl, just a plain kubectl image, which calls kubectl to drain the node, and then the second one is the K3s upgrade image, which will then make sure that there will be a new binary placed on the host, and then the supervisor, and it will be killed so that the supervisor create a new process. That's, I mean, if you go into this repo, you'll find all the scripts, like how that works. There's not really a reason now to go into that. If you use it and you find any things that doesn't work according to your liking, please file an issue or talk about it in Slack. Obviously, because yeah, this should be a tested process already. Okay. So if you go a little bit back to the system upgrade controller, where we said, okay, we created a plan and you can specify a version of a channel. I already mentioned this URL, which is the URL that it's actually running the channel server for K3s, which will actually provide the channels for K3s today. So if you want to use K3s and the system upgrade controller, then we have the channel server running on this address, which will give you the release channels for K3s, which you then can subscribe to if you want to, right? So you can do it all on your own, and you create a plan CRD, or you can create a plan with your specific version. So you can be all in control, like how you want it. You can say, okay, I want this specific version, and then the jobs will be created with that version, and you will have total control. If you want a release channel, then you can have a release channel, and then you can also configure how your clusters should be upgraded, right? So you can exclude nodes. You can. I don't think there's a maintenance window. I think I saw there was an issue for, like, I want a certain time window it needs to be in. I don't think that's ready. Like, I don't think that's being worked on yet. But you can still, like, there are labels I know of that you can apply to nodes to exclude nodes. So if you're like, I don't really want to do these automatically, or I don't really want to do these now, or there's already more control than the default. But like I said, please look at the options and the possibilities. And if you see any use case that is not covered, please file it as an issue so we can look into it, because it might help someone else too. Okay, so if we talk about the channel server, and then we talk about for K3s, it provides the release channels. Then in relation to Rancher, if we would actually hook up Rancher to this URL, then obviously Rancher has its own release cycle, and then K3s has its own release cycle. If we would just hook up Rancher into the K3s, even a stable channel, then we don't really have control over, like, what can actually work. We have all those components. We haven't even talked about all of them. We already covered some of them. we still need to make sure that Rancher is able to use all the set of components that we need to provide this functionality and a certain K3s version that can be supported in that version. So if we would just basically blindly hook up Rancher to the release channel, we don't have the control over what version can be deployed in Rancher, right? Like basically what K3s releases is then available to Rancher automatically based on the channel or whatever we configure, but still there's not really any control over that. So what we did was we have our own copy of channel server inside Rancher, which is run as follows, which is channel server. We pointed to, let me start with the online source and the local source. So we have a local source for the data, and we have an online source because we still need to be able to release out of band if we need to. We specify a config key as K3s, which I will show in the next slide as an example. And then we provide the channel server version, which is basically the version of Rancher in this case, and obviously a refresh interval. So what this does, so I'm going to go into the data later. What this does is it exposes the API endpoint for the available releases. So what happens if in Rancher we have imported a cluster, a K3s cluster, it is recognized, we can edit it, we can upgrade it. When we upgrade that cluster, the available versions will be coming from the channel server, right? So the versions that we get presented to upgrade the cluster that we want to upgrade in Rancher, those versions are retrieved from the channel server embedded in Rancher. Because like I said, we can possibly hook it up to like K3s released versions, but we still want to maintain control on what Rancher can actually support. Does it even work? Like if there are other dependencies from the other components, we still need to be able to control the full chain from Rancher up to managing or upgrading K3s, and that actually works. So this API endpoint is called when you upgrade the cluster. The available versions will be called from this endpoint, which is based on this data. And if I move to the next slide, then like I said, we have an embedded and an online source. So we basically provide two URL parameters to channel server, which is the local data.json, which is retrieved and placed on Rancher build. And then we also put an online release version, which is then out of band, so we can still influence if there's support for other versions needed. We can still release that. The container driver metadata repository is also used for out-of-band Kubernetes releases in Rancher. So apart from managing K3s, just being able to deploy Kubernetes versions other than Rancher was released with, that's also done in container driver metadata. So people who are familiar with that will recognize it. Otherwise, I just told you. So container driver metadata will contain all the data that we can provide out of band to Rancher. Obviously, the copy that we have on build, on release, will also be embedded, mostly for air gap purposes, but just in general, that's the data that is current and that it was released with. So. Okay, so and then the last part is it's configured. So if you actually open the data.json either in the container or online, you will get all the container driver metadata from every Kubernetes cluster version that we support. So I just cut or copied a part of like the K3s. So we actually specify to the channel server, okay, you get this data.json, but please only look at the config key K3s, which is this one. And then you will see here the releases that we present. And then you will see where we control the versions, right? Like where we can control what version of K3s is actually supported in what Rancher version. Because the past channel version, which is then equal to Rancher version that you just saw in the previous slide, is controlled here, right? So we can define a min and a max, and then we can define which K3s version is provided. So this is the controller that I was talking about, where we actually want to control what is possible and what is supported and what is tested, right? So there's a whole process of Rancher being able to be supported and be tested in like a chain from start to end, and we need to be able to provide that, and this is the way that we can do that. Okay, so those are basically the two biggest components that actually do the work, I would say. So let me summarize. So that's the system upgrade controller. and then the K3s upgrade image that actually does the work. So the system upgrade controller that creates the introduces the plan CRD, and if you create a plan CRD with your policy, and in our case we only specify a version because that's the use case that we are describing, it spawns a job. That job has 2 containers, and it uses 2 images, the kubectl to drain, and then the Rancher K3s upgrade image that actually does the work of replacing the binary, killing the process so that it can be respawned with a new version. And then the versions that are available in the configured plan is based on a channel which is provided by the channel server online for K3s, and then embedded in Rancher through our own provided data where we specify versions for specific Rancher versions. Okay, so I hope that makes sense. So then to tie it all together, because that's what I said with like what Rancher does is like tie all these components together. We have a K3s upgrade controller in Rancher, which is a Kubernetes controller. So most of the functionality in Rancher is a controller. So we made a controller for this as well, which basically, if you if you tell Rancher to upgrade the cluster, it will actually use this controller to do all the steps that we just talked about to get from having a K3s cluster to an upgraded K3s cluster. So in this case, it will deploy the Rancher K3s upgrader app in the system project. And if you then go to the other bullet, it says Rancher K3s upgrader is a charge that deploys system upgrade controller. So maybe now, like if you went to the first slide where we say components involved, a lot of components involved. I hope this makes it a bit more clear. So we have a K3s upgrade controller, which is basically the controller that does the actual work of tying all the components together. So it deploys Rancher K3s upgrader app in the system project. So that's basically an app is a chart that contains the system upgrade controller. So like I said, we need the system upgrade controller to upgrade the nodes. So that's the first step of the upgrade controller is to deploy that app in the system project. So we have that CRD. That CRD can be recognized as a plan CRD can be created. And then if you have the plan CRD created, then the system upgrade controller, which is then deployed previously, can do its work and act on that plan. So that's the step that the upgrade controller does. It deploys the Rancher K3s upgrader, which is basically a chart wrapper around system upgrade controller. When that is deployed, it will deploy a plan, and that plan, as you can probably guess by now, will contain the version that we got from the channel server in the UI and that we pass on cluster edit, right? So we edit the cluster, we say we want to go from version, the current version, to a new version, and that new version is provided by the embedded channel server. We say save, and then that channel, that provided new version is then passed into a plan, and that plan will be created in the cluster and say, okay, now we need, the plan will be to go to this version. And then based on that plan, like I said before, the system upgrade controller will spawn jobs, and that job will make sure it will actually happen. Okay, like I said, it can be a little daunting because it's like a lot of steps and etc. You probably have to read this back. I also included the links to either the repo or the code where you can actually trace these steps back. I also highly recommend that you do so that you get a better feeling of how that works. Let me switch to demo to show you how this works, and then hopefully that's the whole point of a demo, is to show you how it works and how you can track it, and then hopefully that also makes it a bit more clear. Okay, let me just let me just refresh this to make sure everything's still live. I have 2 windows because I actually want to show you live when stuff happens. I also have a terminal.
So Sebastian, there is one question, if you don't mind.
Sure.
So
sure.
there is a question about when will K3s be available in the Rancher server UI or not?
To create, or is that the question? To be able
yeah,
to create?
I guess. Yeah.
Okay, so at this point, I can't tell you when that will be available. So we have a project plan on the Rancher repo. I think it's the wiki where we present the 2. So for Rancher, that would be Rancher 2.5. that plan is currently published. Obviously, it can still change. That is the current. That's the current plan of like what we're doing for 2.5. Creating K3s in Rancher. I don't know. That's just not decided yet, or like there's no confirmation that it will be in there. So that's also why I added it in the slides. Is like we in 2.4 it will be creating clusters will be RKE based, and then you can import your K3s cluster to be able to upgrade them. What will be in 2.5 is, and that's also, I wouldn't say constantly changing, but it can still be changed. So I would always refer to that wiki project plan for Rancher for current 2.5 targets. But at this point, I can't tell you what version it will be in. Yeah, that's unfortunately the answer.
Okay, thank you.
Okay, so for people that don't know what Rancher looks like, this is Rancher, just a clean, simple Rancher install. If you install Rancher and you configure a default password and you configure the server URL, so that basically means where Rancher is reachable, you get into this screen, and that's where you have no clusters and nothing, and you can start setting up. You can create clusters, so add clusters basically create, import. You can start configuring security, authorization, authentication, pod security policies, catalogs that you will need. So that's for Helm charts or for Rancher apps, etc. So we're not going to discuss that. The focus for today is if you add a cluster and you want to import it. So we want to import an existing cluster. That's what we're going to do. So I'm going to click on import cluster. I'm going to give it the name very original K3s, and I'm going to click create. So the reason also why I'm showing this is that the import cluster in Rancher is very generic, right? So these are the steps that will be taken for any cluster that you want to manage in Rancher. You can import it. So that's basically this command is what you get for if you have a proper certificate on your endpoint. In this case, it's self-signed. So we will need the insecure curl YAML and then the kubectl apply f pipe to retrieve it insecurely and then apply it. So on the other side, what I have here is a kubectl get nodes, which is a single node K3s cluster. So this is what Hussein showed before. Basically, Hussein showed the curl K3s installer. That's basically what happened here, right? So I ran the curl to the get K3s IO address and then executed that, and then I get a single node K3s cluster. And in Rancher, I create a cluster, which is type imported, so import, and then you get a command, which I'm going to run on the K3s cluster. But before I'm going to do that, I'm going to close this, and you will see here I've created a cluster. So we didn't see any cluster before. We have one cluster now. It's called K3s. It's in pending state because it hasn't reached out yet, and the provider is imported, and it's also important actually because the reason of this part is I'm going to show you that the imported cluster will change based on the version information it will receive as soon as I run the command. So the command that I just copied, I will paste here. You will see it's the curl and secure to the endpoint. We will get a YAML with resources, and I will kubectl apply. And kubectl apply will talk to the local K3s cluster, and that's why I entered kubectl get nodes before. So these agents will be created. This will go very fast. Look at the provider. You will see it just changed from imported to K3s. The reason why it's so quick is because I pre-pulled the Rancher agent image, which is needed to have the cluster talk to Rancher. So if you do this, it will probably take a second or of 10 seconds because it needs to pull the image, the Rancher agent image, which is needed to talk to the cluster. So part one of the demo was to import that cluster and show that from the provider standpoint, it went from imported to K3s because at some point it will reach out to Rancher and will look up the cluster version. The cluster version is 176 plus K3s1. In the first slide, or one of the first slides, we learned that K3s is the identifier for K3s clusters. So the cluster provisioner said, okay, this is now a K3s cluster, which gives us the option to edit a cluster and change the version. So to make it even more clear, if I say, if I create a new cluster, and we go to the overview, you will see this is the state that K3s was in before, and that's the imported. So that's where the difference is made. You can still use imported in Rancher. That means that stuff that goes through Rancher, like authentication, for instance, or using the web UI to manage my cluster, that's all that you can use with imported. As soon as imported change to K3s, you'll get the option to do more with the cluster. In this case, editing the cluster for a new version. But before we do that, we can actually, I want to close this terminal session because that's the only part that we actually needed it for. So I'm gonna minimize all of these, and then what I'm gonna do, just give me 2 seconds. I'm gonna set this next to this. So now we have this. These are similar. This is a similar. These are two browser windows, so not tabs, but windows, looking at the same Rancher installation. And the reason is that because in the left screen, I'm going to upgrade the version, and on the right screen, I'm going to show you what components are involved to make that happen. So hopefully you will get an idea of the steps that I showed you before of like I click on a new version in Rancher. Those are the steps that are taken by all the components involved. And if you see it, you will believe it, I hope. And secondly, you will get a feeling of like what components are involved and how it works. And then hopefully it can be used for your use case. That's one of the end goals as well, obviously. So I'm going to open. So I'm going to edit the cluster here with the version. So before I'm going to do that is what I said in the slides. And I don't want to switch back and forth now with this view. So I'm just going to talk about it again. Is it deploys the system, the chart, the app in the system project. That's what one of the first steps that the controller will do if a Rancher upgrades a K3s cluster. So I'm going to go into the system project, and I'm going to go into apps, because the app is like the chart that packages the system upgrade controller. That's an app that we create using our controller that is called K3s Upgrader. So we will this view will show the app that will be deployed to deploy system upgrade controller, which is responsible for upgrading the cluster into the cluster. So if I go into edit here, so K3s, then you'll see the K3s options, which is based on the cluster type, in this case K3s. And so you will not obviously not see this in any other cluster that is not K3s. So this version dropdown is, like I said before, this is based on the data that is provided through its own channel server, and that channel server is running locally in Rancher based on two data sources, locally embedded one provided on build, and then an online source which gives us the option to do out-of-band releases. So in this case, I have a 176, which is the current version, and I want to go 118.3. So this 118 is coming from, is provided by the channel server based on my Rancher version, which is also the channel server version, in this case, to request versions. If you go look into the presentation and all the data sources I gave you, it should make sense. Otherwise, reach out to me if it doesn't. Okay, so I'm setting a new version. I'm going to click Save here. And what we will see is in the system project, we will see a Rancher K3s Upgrader app. And that app is one of the components involved. It will be deploying the system upgrade controller. So it's now active. So if I switch back to workloads and I go into system upgrade controller, we'll see now that we have the system upgrade controller deployed. And that system upgrade controller, and I will show you the plan CRDs later, because the plan obviously is created by Rancher as well. We deploy this, we create a plan, and based on that plan, we will apply, or we will create a job which will apply the plan. So let me just open that. So this job, which is called apply K3s master plan on IP, so it will do it per node, obviously. And then it has a hash of the plan, which identifies the hash, which makes sure that the hash of the plan which is applied can be related, right? So we know that this job is now to provide this plan, which are all internals, but it will make sense if you actually want to be able to see it. This is like the name of the job, which identifies which plan it's on which node, and then the plan will be referenced as a hash, and that hash, I will show you how you can relate that to the actual plan. So if I open this job again, you will see the two images that I talked about before. So it's the kubectl image, which is just a plain Rancher kubectl image. It's just kubectl. Maybe I think it's Alpine based, so maybe there are some other things, but I think it's just kubectl. And then we have the K3s update image. So this is where my story, where everyone's like, oh yeah, nice, theoretically, blah blah, comes to like practice, and where it actually shows us, okay, this is how it's done. So it will be an init container which will make sure that the node is actually as free as possible to upgrade, and then we will actually upgrade it. And then based on this upgrade, I mean, basically we already saw it on the left side. If people keep track, is that the version is now upgraded. So as soon as this upgrade happens, the new binary is placed, the process is killed, and a new process is started, and that makes the new version. Okay, so one last thing that I wanted to show. Let me check if I have everything. So I mean, it probably goes way too fast if you haven't seen it before, but I hope if you watch it back or if you do it yourself, because that's also obviously what we would like you to do, you will see how this works. So to summarize, the apps, the Rancher K3s Upgrader app was deployed by, as soon as we changed the version, we got the Rancher K3s Upgrader app in the system project, which then deploys the system upgrade controller, which is the component, like I said, that introduces the plan CRD, so we can create a plan, and based on the plan, it will spawn jobs. That CRD, that plan CRD, that plan is then created by Rancher, which I will show you maybe now. Let's see. Oh, my terminal is better in size, so it's probably better seen on terminal. So I will postpone that. The plan is created by the Rancher controller as well. Based on that plan, we will create a job, or system upgrade controller will watch that and create a job. That's this job, and that job contains of 2 containers, 1 kubectl container and 1 the K3s upgrade container, which actually does the work of replacing the binary. And if that's all done, then in the end we have still, I mean, an upgraded cluster, right? So we have the K118.3, and then if I, this is probably bad in terms of visibility, so I will switch to the terminal now, but it's upgraded, right? So this is the cluster version. So if I close this one, and I also want to get out of this, and I go to my terminal, because this is still the K3s cluster, right? So if I go into git nodes, let me just clear this because it's probably going to be super annoying. This is 118.3, right? And then the other part is if you go into get CRD, and I'm going to grab for plan, because that's probably like, otherwise we get all CRDs. If you look at the CRDs in this cluster, we see that we have a plan, so upgrade.get.io, which is a CRD used by the system upgrade controller to spawn the jobs to actually upgrade. And then in kettle system, we have, oh, I'm missing. If you go into the plans, we see we have a K3s worker plan and a master plan. And in this case, we didn't even have workers, but it still deployed a plan for it based on the version. Like we spawned the version, or we told it to upgrade to a certain version, and it will create a plan for that. Before everyone's going to ask, of course, I will open it. And then I will output it to JSON so everyone can see it. And then basically the most important part, so I will encourage you to like watch all of it, but basically this version is the link that I talked about in the slides. It's like we provide with certain versions in the UI. We then say, I want to upgrade to this version, and that's the version that is created in the plan, right? So this version in the plan is then, okay, this is the plan, this is the version that we want to go to, and then the system upgrade controller knows, okay, I'm going to make sure that that cluster goes to this version. And then the hash, if people have looked closely, this is the hash that is also shown in the job name, right? So the job that is created was apply master plan on IP, which is the node name, with, and then this hash. So that's the relation of the hash of the plan. If you are interested on how all of the system upgrade controller functionality works, I would encourage you to go into the repo and see, like there are example plans, there's like more explanations there, etc. There's not really much time to go into detail on that now. I think let me just go to my presentation. I think that's it actually. Oh yeah, so that's for updating. So Hussein, if you have any specific questions on like upgrading,
yeah, we have a few questions around K3s in Rancher. Okay. So one question is, can we add a node into imported K3s cluster from Rancher UI?
No. So so the management of managing K3s in Rancher is basically upgrading the cluster. There's no like other options, like the whole provisioning part, I would say, like in 2.4, the whole provisioning. So that's like creating, but also adding. That's all not included. So upgrading a cluster, that's the part that you get with managing K3s in Rancher.
Okay, so a different question is, does Rancher 2.24 support the upgrade feature, or support what you demoed?
Oh, sorry, is that 2.24?
Yeah.
Okay, 2.4. No. So no. So 2.4, that's the one where it was introduced. 2.4.0 and up. That's where you get this functionality. Before, you don't, like the whole logic of like stuff that's being recognized is not in there.
Okay. So another question is, what is the recommended for production use, RKE or K3s? So yeah, if you don't mind, I'm gonna ready. So RKE or K3s. So you can use both of them in production. There is not really like a preferred one to another, but both of them are production ready from the day one. Also, is there a default dashboard or UI for K3s? No. So there is no basically a dashboard for K3s, but you can always, like what Sebastian demoed, you can use K3s in Rancher. You can import it there, and you can upgrade from there. You can show all of your workloads in there as well. Okay. So
okay.
Yeah, I think that was all the questions. Yeah.
Okay, cool. Yeah, I mean, we can still look on the end. I just want to wrap it up with like the other bullets that I included for completeness on Rancher and K3s. So, like I said, the biggest part of the presentation is obviously managing or upgrading K3s and Rancher. The other thing that changed in or was made available in Rancher 2.4 is that now you can have Rancher HA install on K3s. So that's now a supported option. And the reason why I included this is obviously the relation between Rancher and K3s, but also it used to be RKE only, and that also made it that we would recommend, or basically strongly recommend, to have 3 nodes because of the etcd quorum. Like RKE only works with creating etcd as a storage backend. It doesn't have the flexibility of K3s. So that means etcd quorum for one etcd failure, you will need 3 nodes. So you can read up on that if you don't know that, but that's why we strongly advise to have 3 nodes. So now you have K3s as an option to run Rancher HA starting in Rancher 2.4.0. I didn't include a documentation link, but it's in the documentation. So if you go into Rancher documentation, so it's basically docs.rancher.com installation, you will get both options presented, so K3s and RKE with their instructions, and then you should be able to run that. So that's, I would say, convenient. And the last part that I want to talk about, or actually want to briefly mention, because it's not really something that we want to deep dive on, is that if you do a single node Docker install, which is just the Docker run of the Rancher container, or actually the image which then spawns a container, is actually internally, it also uses K3s. So basically, if you do a Docker run of the Rancher image, which then spawns a container, you will get a locally launched etcd and a locally launched K3s. And then so that's K3s providing you with the Kubernetes components that we need to run Rancher, right? Like I said in the beginning of my talk, is that Rancher uses a lot of CRDs, uses a lot of controllers, so we need Kubernetes to run on. And in Docker run, we don't have Kubernetes by default, so we spawn it. And I included a reference link where you can find where that decision is made, because if you run Rancher on an HA, like if you run Rancher on Kubernetes, which is then usually for the HA installation, it's the decision that is made on that point, right? So if you launch Rancher, then if it's running in a Kubernetes cluster, we spawn our own components. If not, then we use the cluster it's running on. So you can find more information on this link here. Okay, that's all that I have. I hope people are able to follow it. I would say if you have any questions on any component, obviously we will answer questions that are left from this webinar, but also please find us on Rancher forums and the Rancher Slack, the user Slack, to reach out. That's all from my part.
Great. Thank you, Sebastian. Thank you, Hussein. This was great content. If we don't have any more questions, we're going to go ahead and wrap up today. Thank you guys again for your time. Just a couple things before we wrap up. I know many of you guys asked about the slides. They will be shared in a follow-up email along with a link to the recording. And you know, K3s, along with all of our projects and products, are open source. So head over to rancher.com to check them out. There's tutorials and other get started guides. If you guys are feeling up to the challenge, you can now get certified to become a Rancher user. So head over to academy.rancher.com to check out how to enroll. And also for any future events, you can go to rancher.com/events. Thank you all again for attending, and I hope everybody has a great rest of their day or evening.